Every story you've ever heard and every person who has ever lived exists on this single sphere. But as we break orbit and rush backward into the void, the distances involved move past anything our terrestrial instincts were evolved to handle. Our very first physical frontier in space is the Moon, sitting across a void of about 384,400 kilometers. To put that gap in terms of a physical journey, if you got into a car and drove at a constant 100 kilometers an hour, it would take you 160 straight days of driving without a single stop just to cross it. Even this closest celestial neighbor occupies a distance that pushes the absolute limit of what we can comfortably visualize. To reach the Sun, we introduce a larger measuring stick. The distance from Earth to our star is 150 million kilometers, one astronomical unit. A commercial jet would take 19 years of continuous flight to cross that single AU. Trying to reach our planetary neighbors, like Mars, introduces complex orbital dynamics. Depending on the day, the physical distance between Earth and the red planet stretches from 55 million kilometers to over 400 million kilometers. Out at the physical edge of our planetary neighborhood sits Neptune, 4.5 billion kilometers away. Sunlight racing across a vacuum takes over 4 hours just to reach its atmosphere. Despite our success in launching rovers and mapping orbits, humanity remains physically trapped inside this localized pocket of a single star system. Since biological travel over these expanses is currently impossible, we send robotic proxies into the dark instead. The farthest of these is Voyager 1. Launched in 1977, Voyager 1 has traveled for more than 4 decades, pushing outward to a distance of over 22 billion kilometers from Earth. In 1990, the astronomer Carl Sagan requested that the probe turn its camera backward to capture our home planet one last time from the edge of the solar system. The resulting pale blue dot photograph shows Earth as a single, nearly invisible pixel caught in a faint beam of light. This image places the sum total of human history on a speck suspended in a sunbeam. It is a perspective that isolates us within a silent, immense vacuum. Once we aim for Alpha Centauri, the nearest star system to our Sun, the astronomical unit becomes useless. We switch our scale strictly to light years. Alpha Centauri is 4.4 light years away. Traveling at its current speed, Voyager 1 would need 70,000 years to reach it, placing interstellar star hopping far beyond our physical reach. This map shows the Milky Way galaxy, and that tiny pulsating dot represents our true electromagnetic footprint, the human radio bubble, radiating outward for 100 light years. This sphere contains our entire broadcast history. Its boundary is marked by the transmission of early mid-century television and radio signals, the very first moments we announced our presence to the galaxy. Beyond that microscopic bubble, the hundreds of billions of stars occupying the rest of the Milky Way are oblivious to humanity's existence, simply because our signals haven't reached them yet. Pulling back, we mapped the local group, a 10 million light-year cluster of over 50 galaxies. This sits within the Virgo supercluster, holding thousands of galaxies across 110 million light-years. Finally, we reach the Laniakea supercluster, a 500 million light-year gravitational web anchored by the Great Attractor. At this scale, we are mapping superstructures so large that our entire recorded history is reduced to a single, mathematically invisible point. Finally, we reach the edge of the observable universe, a sphere measuring an astounding 93 billion light-years across. This creates a paradox. If the universe is only 13.8 billion years old, how can we observe a space that is 93 billion light-years wide? The answer is cosmic expansion. Ever since the Big Bang, the fabric of space itself has been stretching, forcing celestial bodies further apart over time. Because this stretching compounds over distance, the most remote regions of space are actually receding from us faster than the speed of light. This means the true size of the entire universe beyond that observable edge remains unknown and potentially infinite. The expansion of space ensures that vast portions of the cosmos remain permanently out of reach. We are left to look up from our small corner of the universe, mapping the boundaries of an expanse we can see but never touch.